Hello everyone. In this video, we're going to be solving a functional equation, an interesting one. We have f of x defined as a piecewise defined function. So if x is odd, f of x is x plus 3. If x is even, then f of x is half of x. So this is kind of like a function from integers to integers, or I guess you could say non-negative integers to non-negative integers. And we have f of n equals 3, where the f is applied 4 times to n when we get a 3 at the end. So we're going to be finding the values of n for which this equation is true. So we're going to be solving for n, in other words. So the definition for f is given, but we kind of need to work backwards, because if you kind of think about it, whenever you have a function with so many compositions, let's just take 2 of them. For example, if f of n, or let's start with the first one. Let's say f of n is equal to a. In this case, you kind of have to apply f inverse on both sides, and that's going to give you f inverse of this equals f inverse of this. And f inverse and f will actually cancel each other out, and from here, n is just going to be f inverse of a. So if we only have one application of f, then we just need to find the image under the inverse function, so we kind of need to reverse everything. Make sense? So that's what we're going to do, and we're going to be thinking backwards. We'll start with the 3 and think about how we could get to 3, obviously. So it kind of looks like this. We have a number, something, you can call that t. Let's call this whole thing t. Then we kind of have an equation like f of t equals 3. So we need to think about what would lead to 3. And by looking at the definition, the result, because the output is 3 here, it's going to be one of these. So we're going to be setting each of these equal to 3 and then solve for x and see if that makes sense, if it's consistent with the definition of the function. Make sense? Okay, great. Let's proceed. Start with 3. So we basically have, one more time, f of x is x plus 3 if x is odd, and it's half of x if x is even. Of course, this always produces integers, because if x is even, it's divisible by 2. And if you add 3 to an odd number, you're going to get an even number. So they're going to oscillate, sort of. Anyways, so to get to 3, what can we have? We could start off with the 0, because if you set x plus 3 equal to 3, this gives you x equals 0. So you kind of need to read this definition as, if x is odd and x is 0, then f of x is going to be 3. Make sense? Wait a minute. 0 is not odd, so it's not going to work. Let's use the other definition. Half of x is 3 if x is even. And in this case, x is 6, so it satisfies the requirement. Therefore, 6 actually is going to lead to 3. And 6 is the only number that is going to produce a 3 under f. Make sense? Okay, great. So as you know, with functions, we can have more than one value that gives us the same output. But in this case, the input and output pair is unique. Make sense? Okay. So we kind of have something like this. We start with the 3 at the bottom of a tree, and actually it has to come from a 6. Make sense? 6 is even, half of 6 is 3. That's what it is. But we need to go back, because this is just one application of f. So let's go backwards. All right, great. Let's continue. Now, this time we're going to set our values to 6. So let's go ahead and erase these and set them equal to 6. And I'm going to keep using the same definition so we don't have to scroll up and down like crazy. What happens if x is equal to 6, or I mean the output is equal to 6? In this case, from here we get x is equal to 3, and from here we get x equals 12. By the way, the top one is for odd numbers, so this works, and the bottom is for evens. That also works. In this case, we have two inputs that produce a 6, 3 and 12. Does that make sense? So it could be a 3 or it could be a 12. Awesome. Now, here's the thing. We know that 3 is only produced by 6, so I can kind of write this as follows. You can only have a 6 that produces a 3, and then the 3 produces a 6, and then 6 produces a 3, so on and so forth. We want to get to this 3, and we have to do it in 4 steps, right? Because f was applied 4 times, as far as I know. So we kind of need 4 arrows. Each of these is an application of f. For example, if you take this, it's kind of like f, f, and f. You applied it 3 times. but you need 4 times, which means 6 can only be produced by a 3, right? Is that correct? Yes and no. Actually, that's not correct, because 6 can actually be coming from a 3 or a 12. So it's kind of like this. It's going to come from a 3 or a 12, right? So there are 2 numbers. Actually, those will work, because notice that if you apply the f 4 times, 1, this is the first application, 1, 2, 3, and 4, you're going to get 3. So 3 will work and 12 will work. But we have to proceed with the other 12. Where does 12 come from? Let's think about it. Erase these again and set the outputs equal to 12. And from here we get x equals 9 and x equals 24. Obviously, the top one is supposed to be odd and bottom is even, so they both work. 9 and 24. You see what I'm saying? 9 and 24. Now think about the very definition. The definition says if x is odd, you have to add 3, which validates the 9 here. So 9 and 24 are both inputs that produce 12. Make sense? But we do need more applications, obviously, because we do need it 4 times, right? If you apply f 3 times, 1, 2, 3, we do need 4 times. So we still need to go up a little bit more from the 9 and the 24, right? So those are branches, but we need one more. How do you get 9? Let's go ahead and set these numbers equal to 9, okay? If you set them equal to 9, you're going to get 9 here and 9 here. This is going to produce x equals 6, and this is going to produce x equals 18. But remember, the top definition, x plus 3, is only valid for odd numbers, but 6 is not odd, so this is invalid. So the only number that will work in this case is 18, which means 9 can only be coming from an 18. And since this is f applied 4 times, this is also going to be one of the solutions. You see where that ends? We have to go backwards 4 steps. Okay, great. Let's go ahead and take a look at 24. We need to go back one more time. And now this time we're going to be setting the outputs equal to 24, because that's what we want to get as output. So 24, 24. From here, x becomes 21, and from here, x becomes 48. Let's check both. Now remember, the top one is supposed to be odd, and 21 is odd, and 48 is even. Of course, it's always going to be that way. And now 21 and 48 are both good. 21 and 48. By the way, you could take these numbers and just check each one. For example, start off with 21. 21 is odd, add 3. 24 is even, divide by 2. 12 is even, divide by 2, and divide by 2. Divide by 2. So 4 times, you get to 3. Start with 48, half of that, half of that, half of that, half of that. Since 48 contains 2 to the 4th power, you're just going to do it 4 times and still get an even number. Make sense? I mean, after the 3rd, of course, you're going to get a 3. So all these box numbers are solutions, and there are actually a total of 5 solutions. In other words, 3, 12, 18, 21, and 48. And that brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.